Looking at section 4.8, applications of trigonometric functions, we are going to solve a right triangle, solve problems involving bearings, and model simple harmonic motion. So a little review from geometry and some trig. Solving a right triangle means finding the missing lengths of its sides and the measurements of its angles. We will label right triangles so that side A is opposite angle A, side B is opposite angle B, and side C, the hypotenuse, is opposite right angle C. So we have lowercase a, b, and c to represent the sides and capital A, B, and C to represent the angles. When solving a right triangle, we will use the sine, cosine, and tangent functions rather than their reciprocals. So for example, if they tell us to let A, which would be angle A, be 62.7 degrees, I'm going to go ahead and label that 62.7 degrees, and side A is 8.4, side A is 8.4. They want us to solve the right triangle, rounding lengths to 2 decimal places. So if we have an angle of 62.7 and we have angle C as a right angle, we can identify angle B by adding the angles that we have together, subtracting it from the 180, or just take 90 degrees, subtract the 62.7 to figure out what angle B is. Angle B is going to end up giving us a 27.3 degrees. So now that we have all of our angles, we need to focus on our side lengths. All we have is side length A, which is an 8.4. Now you can choose whichever angle you want to work with, either angle A or angle B. You can use your sine, your cosine, or your tangent functions to start setting up those ratios. In the case of our notes, we have tangent B. They're going to pick on angle B. And from angle B, they said that we're going to use the tangent function of B. Well, the tangent of B means that we're going to have our opposite divided by our adjacent. So they're going to set it up with angle B over, side B over side A. So that means our tangent of B is going to equal our B value of our unknown, although I don't want tangent of B, do I? I already figured out what that degree is. I want the tangent of 27.3 to equal my side length B divided by my side length of A, 8.4. Now to get B all by itself, we would undo divide by 8.4 by multiplying by 8.4. What I do to one side, I'm going to do to the other. And all I have to do is plug in my calculator, 8.4 tangent of 27.3, which means that side length B is going to equal, double check that your calculator gives you the same value. You should end up with a 4.34. So then we have identified what side B is. We can go about finding what side length C is. Now, you have A and B. You could use a Pythagorean theorem to find out what side C is. Your A squared plus B squared equals C squared. Or continuing using some of our trigonometric functions, they went and said, we're going to find our last side C by using sine of A. So if I have the sine of A, if I look at angle A, if I'm using the sine, that means I'm going with my opposite, which is A, divided by my hypotenuse, which is C. So that means we're going to have our sine of our A is 62.7 is going to equal our side length of A, which is 8.4, divided by our side length of C. Now this one has a little bit more work to do in order to get the C all by itself. We'd start by multiplying the C over and then dividing by that sine of 62.7 to the other side. Divide by sine of 62.7. That means our side length C is going to equal an 8.4 that's being divided by the sine of 62.7. So if you take and you plug that into your calculator, you would end up with C is equal to a 9.45. And again, they had wanted 2 decimal places, so make sure that your calculator, you round those correctly. Let's try another one. It says finding a side length of a right triangle from a point on level ground 80 feet from the base of the Eiffel Tower. The angle of elevation, looking up, is 85.4 degrees. Approximate the height of the Eiffel Tower to the nearest foot. So if we take a look at the information that we have, they tell us what this angle of elevation is. Elevation means that our person would be looking up. We have an 85.4. We are trying to figure out what the side A is, and we have that we're 80 feet away from the Eiffel Tower. So we need to figure out which trig function is going to give us an opposite over an adjacent. That means we need a tangent function. So the tangent of 85.4 is going to equal the opposite, which is side A, divided by our adjacent, which is 80. And if we solve to get the A all by itself, multiply that 80 to the other side. So if you type in your calculator 80 tan of 85.4, that's going to give us our side A. Again, double check that your calculator is giving you the right answer. We end up with approximately 994 feet. So it's approximately 994 feet tall. Let's look at another example. Finding an angle of a right triangle. A guy wire is 13.8 yards long and is attached from the ground to a pole 6.7 yards above the ground. It says to find the angle to the nearest tenth of a degree that the wire makes with the ground. So our guy wire, the wire that's being located here, is what is going to be our hypotenuse. So we have a 13.8 yard long guy wire, and it is attached to the ground to a pole that is 6.7 yards above the ground. So the pole itself is going to be our 6.7. So find the angle to the nearest tenth of a degree the wire makes with the ground. So we are looking for this angle A. So let's see what we have. When we look for angle A, the information we are given is we have an opposite and we have a hypotenuse. So what function do we need for opposite over hypotenuse? We need to figure out the sine of angle A is going to equal 6.7 divided by our 13.8. Now, in order to solve for what that A value is, this is where we need that inverse tangent. So we're going to plug in our calculator that sine -1 of 6.7 divided by 13.8. So again, make sure that you're plugging it into the calculator correctly. You need some extra parentheses in there to make sure that you're taking that inverse sine of that whole fraction. So your calculator should tell you approximately 29.0 degrees. So we're about approximately 29.0 degrees. That angle makes with the ground. Trigonometry and bearings. It says in navigation and surveying problems, the term bearings is used to specify the location of one point relative to another. The bearing from point O to point point P is an acute angle, the measure in degrees between ray OP and the north-south line. The north-south line and the east-west line intersect at right angles. Each bearing has three parts: a letter N or S, the measurement of an acute angle, and the letter E or W. So in general, what happens when we are looking at any sort of north, south, east, and west, right? We have our north, we have our south, we have our east, we have our west, or never eat shredded wheat, or if there's other sort of means that somebody told you in terms of memorizing those. So what we're going to end up doing is we are going to read our bearings. We're only going to deal with acute angles. Acute angles means that we're going to have an angle that falls somewhere between that north and that east line, somewhere between the south and the east line, somewhere between the north and the west line, or somewhere between the west and the south line. So on the next part, it shows us that if the acute angle is measured from the north side of the north-south line, then we're going to write N first. As a second, we write the measure of the acute angle. If the acute angle is measured on the east side of that north-south line, then we write E last. So if we were to look at this example, they have N40 east. That means that we are starting at the north. We are going 40 degrees towards the east. So it's going to be red, north, 40 degrees east. That's what that angle is going to look like. At the bottom part, it says, if the acute angle is measured from the north side of the north-south line, then we write N first. Second, we write the measure of the acute angle. If the acute angle is measured on the west side of the north-south line, then we write W last. So this one here tells us we have north, 65 degrees west. So starting at the north, we're going to go 65 degrees towards the west to develop this angle here. So if the acute angle is measured from the south side of the north-south side, or north-south line, then we write S first. Second, we write the measure of the acute angle. If the acute angle is measured on the east side of the north-south line, then we write E. So if we had, for example, south 70 degrees east, we have south going to the east 70 degrees. And let's try a couple. It says use the figure to find each of the following. So they want to know the bearing from O to D. So if I were to find O to D, that means that we are looking at this angle right here. O to D. That's the ray that we're looking at. So we are going to start with our north-south side. So the north-south line, it looks as though we're going from the south towards the east. So we're going to have south we're going to have 25 degrees towards the east. If we were to look at the bearing from O to C, so let's go and find O to C. O to C, where is that located? Well, that's also south, going towards the west. How many degrees? Now, they show us this piece of 75, which means how many degrees are left in between that south side and that angle? Well, we'd have a total of 90 degrees for that whole quadrant, which means that we're going to have 15 degrees here. So going from the south, we're going 15 degrees towards the west.